Okay, so I assembled the frame and I went and I tightened all the bolts. Then when I went to put on the braces at the bottom, none of the holes would line up. So I had to loosen all the bolts because the legs were not, they were too far apart or too close together, none of the holes would line up. So I loosened all the bolts on the legs. I didn't loosen the bolts on the middle frame, this one, and this one. I did loosen the ones on the end. And that way I could manipulate all my legs. So now I got all the bolts in it and all the bolts are loose. I may still go back and loosen these just so I can make sure it's settled down flat. Now, you notice now there's 2x4s underneath the legs. Well, the reason is I thought the floor was level. I thought the floor was flat. The floor is neither level nor flat. It's got waves in it, especially around these places where they patched the floor, because I guess at one time there was a in-ground lift, and these patches are in every single bay in a pattern. So there were lifts all along through here, and then of course they filled them in at some year back in the 80s or 90s, and they went with above ground lifts, and you can see the evidence of the above ground lifts also. They just cut them off at the floor. I'm gonna worry about that later. But I did not get the leveling feet with the kit. The leveling feet were an additional $300 to get the kit of the leveling feet. And I thought that was a little extreme for leveling feet. But now I'm thinking, I wish I had, because I wouldn't have to be doing 2x4 leveling. Now this is only temporary. You see I got some shims in it, I got it blocked up, but you can see the difference. That 2x4 is sitting on the slab, and down here I've got a piece of 1/2-inch plywood and a stack of shims. So it really gets crazy as it gets toward the door. Now I can understand a gentle slope going toward the door so any fluids or water would run out the door. But that would be even. It's not even, it's like this. So anyway, I'm gonna level it with the 2x4s. These are the 2x4s that were used to crate up the linear rails. Because the linear rail is one piece long, they built a separate crate for the 2 linear rails, and that's what the 2x4s are from. So they're the perfect length. What my plans are is once the table is level and I got it running, I will use the plasma table to make brackets for all the legs, because there's already a set of bolt holes. You see there's bolt holes here, and there's bolt holes on the inside. So each leg has a triangular shaped plate that goes in it, and then it had an adjustable foot. What I'm gonna do for the feet is just use a 3/4 inch or maybe a 1 inch or a 7/8 inch grade 8 bolt. I'm gonna make the triangle plate with the plasma table that'll fit right in there, bolt it in the corner, have a grade 8 nut welded to the plate where I can screw a bolt in and out. And then all I gotta do is put a wrench on the bolt, turn it in and out to adjust that particular leg up or down. That will be way cheaper than ordering the $300 leg kit. Plus, it's got to come from Vegas, so I'm sure the $300 leg kit will come with a $150 or $200 shipping. If I would have ordered ahead of time, the shipping would not have affected the shipping on that thing. The shipping on that thing was $1,300. They would have thrown the leg kit in there and shipped it without adding any shipping to it. So if I order them now, I'm looking at $300 for the parts, plus probably $150 for shipping, because they're going to be heavy. So I might as well just build them myself. I can build them for probably under $100. I can get the plate, I can let the table cut the plate out, I can go to Tractor Supply and you can buy the bolts by the pound, which is half what you would pay if you went to Lowe's for the same bolt. Exactly half. So I can do it with grade 8 bolts. The minimum I'll do is a 3/4 bolt, 3 inches tall. The tensile strength on a grade 8 bolt, a 3-inch bolt, a 3/4 bolt would be plenty. But a 1-inch bolt or a 7/8 bolt would have a coarser thread, and a 1-inch even coarser than a 7/8. The coarser the thread, the greater the strength of the thread. So we're not worried about the tensile strength of the bolt or the shear strength of the bolt, because we're going to be putting the bolts under compression. When it comes to compression strength of a bolt, it is 100% the thread that supports the compression strength of the bolt. The tension strength and the shear strength is the bolt and the threads, where when it's in compression, it's just the threads. Unless the bolt goes in and bottoms out against something, which that's not what we're doing here. So I may go with a bigger bolt just so it has a coarser thread, which would give even more compression strength to support the table. Now, granted, this table is designed to hold umpteen thousands of pounds. It says it's rated for a 5x10 sheet of 1.5-inch thick steel. So 1.5-inch thick, 5 foot by 10 foot, that's probably going to be around 5,000 or 6,000 pound piece of metal. I'm never going to put anything that big on here. The legs are rated to support that. Fine, great. I'm never going to support that much weight. So the 3/4 bolt will probably be fine. However, the bigger bolt is going to have a bigger head, and the bigger head will make a bigger foot on the concrete. If the foot is too small, it may over time start pressing into the concrete, because this may not be the best slab. You know, it's old. This building's probably 60 years old, maybe older. Anyway, that's where I am now. Okay, I've made some simple changes. So this is the remnants of the crate for that's the crate the bulk of the thing came in, but the linear rails came in a crate by themselves because they're 12 feet long. So the table offered, I got the $900 add-on for the gear reduction motors, an extra I think $200 for this homing kit, which are these two devices here. They just tell the computer when the unit is at 0x0y. This is already part of the kit. This already comes with it. This just tells you when the torch is at max. So they offer the leveling kit with it for another $300, and I said, well, I'm on a shop floor, it's flat, it's level, I don't need the leveling kit. I get here, the floor is not flat and it's not level, so I used the 2x4s that were in the crate, and you see I got a shim under it, and here I got a piece of plywood and shim, and here I got shims and a piece of plywood. Here I've got a piece of 5/4 board. Here a piece of plywood and shims, and then this one's just shimmed on the floor. So it's perfectly level now, and when I get weight on it, I'll go and I'll shim under the middle legs. They're not concerned because this is a one piece here, so there's no sag here. So, but to make it hold weight, I'll shim under those when I get the weight on it, the water pan and everything. So some things I've done to add to it. It comes with a it doesn't come with anywhere to mount the control box. Now on the SparX Pro, I want to say that's what they call it, the Pro, there are 2 holes already drilled in the control box to mount the SparX. This box is mounted on the left front corner, and the holes are already in the box. So what I did is I drilled some holes in my leg, but I went ahead and drilled 4 holes. So you have to be careful. These holes were already in the box, these holes weren't. So I had to make sure, be real careful when you push these holes through the box that you don't hit any of the interior components. if you look, if you come 4.5 inches, 4.25 inches from the edge of the box, you have clear space to put holes. So I got 4 bolts, and I bolted the box to the unit. I put it way back here on the back instead of up on the front because it only comes with like a 6-foot extension cord, and there's my outlet. So I just want to be able to run it here. And then there's all my cables that go to it. Now it also comes with just a 4-foot or 6-foot, I want to say a 4-foot USB cable. I went to Office Depot and got a 16-foot USB cable. And so that USB cable can come up here to this little table. Now this, I also got this from Office Depot. So you see it's got wheels and it's got a hydraulic. So this is standing height working. I can take it and, oh wow, I can push it down to a sitting height. So there's a nice sitting height, and then it's just got this little tab, and you just squeeze it, and the hydraulics lift it up. So standing height, and it's on wheels, and there's my USB cord. So what I'm gonna do is they recommend that you've got to have, so this cable here goes to the sensor up there. It cannot go in the cable track because the cable track moves, and it doesn't. It stays mounted to the unit under here. It stays mounted. You don't move it. So they say they want you to lay it in here beside this, but I think this moving is going to eventually chew it up. So I think what I'm gonna do is just get some of those, either drill little holes in here every so many inches and just zip tie it to the side of the tray, or get some of those double stick stick bases where you can zip tie stuff to it, and then I'll zip tie my my USB cable along with it. So here I'm trying to get some of my cables in control before they go to the box. Now, as far as this cable that goes to this unit right here, all I did is, there's already a hole drilled here and a hole drilled here. I just kind of zip tied it to here. It's one of those right there, right there, and then the other one is the Y motor. Now you can't run the Y motor cable in with the rest of the cables because it does not come back and forth with the X axis. It has to stay over here. So again, they recommend just laying it in the tray, you know, when they just want you to lay it in the tray. But I think that thing, you know, since it's not really meant to, you know, I'm afraid that if it gets against it, it'll just chafe it as it comes and goes. So I just tucked it in that groove right there. Look, see, it's just neatly tucked in that groove. And then again, there's already holes drilled. I just zip tied it and run it to my Y motor. Yes, I know that says S. The Y motor box swings this way, and it puts this flat edge back here, so it covers that hole, but it also puts the motor's weight on this linear bearing, which has the top weight on it. Well, if you put the motor forward, then it evens out a little bit, I would hope anyway. So you got the two linear bearings, see, so not all the weight's on that rear bearing. You put this up here, maybe there's some weight up here. So yes, it says S, but it's actually the Y motor. And then of course this one is actually the S motor. And you think, well, it gets too far forward here, but no, it doesn't, because it gets to that thing and it stops, so it never interferes with that. So that was just something I did. And the motors, I want to say, when the motor was mounted on here, the cable came out this side of the motor. So I just unbolted the motor, rolled it over, and bolted it back on. So the cable comes out neatly on the back, goes to my zip tie. X motor. Again, the cable exited the motor, I think here or here, I can't remember. I clocked it and rolled it so I could get the motor tied here. And then those are the holes for this thing. If you do it this direction, I just dropped a zip tie in there, and kind of I rolled my Z motor. Well, the Z motor, I installed it. It wasn't already installed, so I put its cable to the rear, put this cable to the front, so everything neatly goes. And I just got the zip tie loose. It's not tight on there, but it keeps them in place. So other than that, I'm pretty good. I am a little aggravated that the cable that goes to the plasma cutter, this is the cable that goes to the plasma machine. They recommend that the plasma machine be at least 6 feet away from this box. So what do? They send you a 6-foot cable. Really? 6 feet? Come on now. You have to stretch the cable just to get the recommended 6-foot difference. This cable should have been 8, 10, maybe even 12 feet. You see how much slack is left over in all those cables. There's plenty of slack left over in all those cables. Some of them way too much slack. I don't know how they say they're custom handmade and everything, but how do they get their length so crazy? Because no matter how you set the machine up with the track on the left side or the right side, no matter how you set it up, the cables, you use different cables depending on left and right, because the Y motor and the slave motor are inverted when you invert the track on each side. So it doesn't matter. The cables should all be the same length no matter how you set it up. So by the time they get to the end of the track feed, whether it's on this side or here, they should all be the same length out of there, but they're drastically different. The only cable that would make a difference is the X home cable. The X home cable, if you home on the left, the X home cable doesn't have to go across the gantry. If you put your cabling system on the right, the X home still has to be on the left. So then the cable would have to cross the gantry, but that would only add 60 inches to the length of the cable. So that's the only cable that should be longer than the rest. It should be 60 inches longer than the rest of the cables. But every single cable they've got, I don't know what they did, but they custom made them, but they're lousy. None of them are right. So I'm a little anal about stuff like that. I may go in and re-lengthen all the cables, in other words, shorten them all to be working length. Because look, all they have to do is come to here, and no matter where I set this, they should all terminate at the same length. They shouldn't be several different lengths if they custom made them. And I think I'm just gonna take this end off and take the other end off of the plasma cable and just make a longer cable. It needs to be at least 10 feet long, because what I'd like to do is put the plasma machine right here, and you see there's plenty of the torch cable that can reach it. So if that cable comes into the back of it, the torch cable comes in the front of it, that way if I want to do a hand torch, I could just take the machine torch out of the machine and put a hand torch in it, and I'm gonna have a welding table set up right here so I can torch with the hand torch. So anyway, there's just a few things that they could tweak. These 4 bolts were locked down when you bought the thing, and then you have to put these 7 bolts in when you assemble it. These 3 holes and those 4 holes, there was a lineup issue where I couldn't get the bolts to start, so I ended up having to loosen those so that would wiggle. Then I could line up all the bolts, and then I locked everything down together. Those 4, they seriously over tightened them, so it was almost impossible to get them loose without bending the Allen wrench. So maybe they could not tighten them so tight, because you really should loosen all 4 of those before you thread these 7 in, because like I say, these 3 are on a different piece of metal than those 4. Those 4 go directly into this. These 3 just go directly into this plate. So if those 4 are locked down and this is not lined up right, you'll never get these bolts in their holes without stripping them or galling their threads. So I just broke those 4 loose and then got them all started, ran them in by hand, then put those all back down, and then tightened everything at once. But those should not have been super tight. Other than that, everything is pretty, straightforward. Everything went pretty well. I got it all ready to go. You see I'm getting the pans ready now. I'm getting ready to put the water pans in it. But once I level this, it's perfectly level. It's perfectly flat. It's perfectly square. Once I lock down the nuts and bolts, it's rigid as hell. Before, when everything was loose, you could wiggle it around. But once you locked it down, once you tightened all the bolts, it is solid. It's not going anywhere. Which makes it nice and convenient. And then, like I said, I just mounted that on there, so I'll rewire it and it's good to go. So, that's the video for now. Just running my head mainly. So, yeah, I'm ready to start burning some material. Out.